The event loop explained in 2026. 1. JavaScript is single-threaded. JavaScript runs on a single thread, one call stack, one thing executing at a time, and yet it doesn't freeze while waiting on a network request or a timer. That's the event loop's job. It lets JavaScript hand off waiting work and come back to it later, without blocking. Console.log 1 start. setTimeout.co console.log 2 timeout callback 0. Console.log 3 end. / output order 1 start 3 end 2 timeout callback. Even with a 0 milliseconds delay, the timeout callback runs last. The call stack always finishes everything it's currently running before the event loop hands it anything else. 2. Call stack, web APIs, and the callback queue. There are 3 moving parts to keep in your head. Call stack, where your currently running code actually executes, one frame at a time. Web APIs or node APIs, where setTimeout, fetch, and file network operations run in the background, outside the call stack. Callback queue, where finished background work waits its turn to run on the call stack. The event loop's entire job is simple. Check if the call stack is empty, and if it is, push the next item from the queue onto it. That's the whole mechanism. 3. Promises jump the queue. Not all queued work is equal. There are actually 2 queues, and promises get priority. Console.log 1.start, setTimeout.co, console.log 2 Macrotask setTimeout. 0. Promise resolve.then.console.log 3 Microtask promise. 0. Console.log 4 end. Output order 1 start.4 end 3 Microtask 2 Macrotask. Promise callbacks go into the Microtask queue, and setTimeout callbacks go into the Macrotask queue. After every single task, the event loop drains the entire Microtask queue before it touches the next Macrotask, which is why the promise always wins, even against a 0 milliseconds timeout. 4. A classic interview question. This exact pattern shows up constantly in interviews. Try to predict the order before reading on. Console.log A, setTimeout.co, console.log B. 0. Promise resolve.then.console.log C, then.console.log D, console.log E. Order A, E, C, D, B. A and E run first because they're synchronous. Then the entire Microtask queue drains, both .then calls, C then D, before the event loop finally gets to the Macrotask, B. 5. Async await uses the same Microtask queue. Since async await is just syntax sugar over promises, and await pauses a function and resumes it as a microtask, exactly like a .then callback. Console.log 1.start, async function example. Console.log 2 inside async function, await null. Console.log 4 after await runs as a microtask. Example. Console.log 3 end. Order 1.start, 2.inside async function, 3.end.4. After await. Everything before the first await runs synchronously, immediately. Everything after it is scheduled as a microtask, which is why it runs after the rest of the synchronous code, but before any set timeout. Misconceptions to unlearn. Set timeout FN0 runs immediately. It doesn't. It still waits for the call stack to clear and the microtask queue to drain first. JavaScript is multi-threaded because promises run in parallel. It isn't. Promises don't run code in parallel, they just reschedule when callbacks run. Async code runs on a separate thread. The waiting, network, timers happens outside JS, but your callback still runs on the same single thread, one at a time.